welcome. Listen, I want to speak directly to you today, my brothers out there in the field, the engineers and operators who are running the front lines of our industrial wastewater and UPW pure water filtration systems. So take a slow, deep breath, all right? Because what we're covering in this explainer today is incredibly serious. We're looking at a critical, literally life-saving standard operating procedure, an SOP for your plant's biological processes. You know as well as I do when a toxic shock hits, man, it can completely wipe out your entire system in a matter of hours. It's devastating. So I'm here to walk you through exactly how to prevent that nightmare. Okay, let's dive right in.
Here's a quick look at the agenda for this explainer. We're going to cover the toxic shock nightmare, hunting the root cause, dealing with metals and solvents, handling acids and disinfectants, the crucial first-hour checklist, and finally, our overall prevention strategy.
All right, Section 1, the toxic shock nightmare, critical emergency.
And guys, it truly is a nightmare. An acute toxicity event is a critical emergency that can literally annihilate your aerobic bacteria and collapse your entire biological treatment process in just hours. I mean, we're talking severe regulatory violations and massive, massive recovery costs. The stark contrast between a healthy tank and a dying one is immediate. In a healthy system, we're always striving for that rich, brown, activated sludge, right? It has that earthy smell, the water is crystal clear, and it settles beautifully. But when you're in the middle of a toxic shock, the signs are just brutal. You aren't going to smell earth, you're going to get hit in the face with a harsh chemical smell, stuff like solvents, phenol, or sulfur. Visually, you might see this thick, dark brown, or even black foam. Or honestly, sometimes the foam just vanishes entirely because, well, the bacteria are dead. The water in the aeration tank turns this murky gray or milky white, and your sludge volume index, your SVI, just completely spikes because the sludge completely loses its ability to settle.
So, what does this all mean when we look at the data? Well, if you see your oxygen uptake rate, your OUR, drop by more than 50% compared to your baseline, that's it. You have a confirmed acute toxicity event. Because the bugs have just stopped breathing altogether, your dissolved oxygen, your DO, is going to spike abnormally. We're talking shooting up above 4 to 6 milligrams per liter. At that point, your system is literally choking to death.
Moving on to Section 2, hunting the root cause. Find the poison.
Now, once you've actually confirmed the shock, look, panic is absolutely not an option. You and your team have got to instantly shift gears and act like detectives to track down the exact source of this poison. So here's your 5-step investigation process. First up, confirm the speed of the microbial decline by measuring your OUR every 2 hours. Second, get your lab moving immediately. Pull those samples from the influent, the equalization tank, and the aeration tank. Run them for heavy metals using ICP-MS or solvents using GCMS. Third, start your internal investigation. Check the flow meters, pull the logbooks, and frankly, interrogate the shift leaders over at the production facilities. Did someone dump a tank without telling you? It happens all the time. Fourth, roll the tape. Check your security cameras in the discharge areas for the 2 hours before and after the event and pull the data from your online sensors. Finally, step 5. Run specific toxicity tests like respirometry or ATP to nail down the exact culprit.
Okay, Section 3, metals and toxic solvents, targeted recovery plans.
So let's say you get hit with heavy metals. We're talking chromium, nickel, copper, zinc, or lead. Your timeline here is incredibly tight. In that very first hour, hour 0 to 1, you absolutely must bypass the incoming stream to an emergency holding tank. Just cut it off entirely. Then, over the next 1 to 24 hours, you need to add precipitants, things like sodium sulfide or calcium hydroxide, right into your equalization tank. And you got to heavily increase your waste-activated sludge, or WAS, to physically remove the metals that have already latched onto the dead sludge. For the longer term, say days 1 through 7, you're going to need to bring in backup seed sludge to rebuild your biology. Keep tracking those metals every single day until the effluent drops below 0.5 milligrams per liter.
Now, what if you're dealing with toxic solvents or organic chemicals? Again, in hours 0 to 1, isolate the source immediately and start diluting that equalization tank with clean water to get the concentration well below those lethal limits. Between hours 1 and 24, if you've got access to an advanced oxidation process like a Fenton process, use it. You're also going to need to crank up your aeration heavily, really heavily, to physically strip and evaporate those volatile organic compounds right out of the water. And make sure you're adding nitrogen and phosphorus nutrients to give those stressed out bacteria a fighting chance. Over the following week, you'll likely need to dose specialized microbes that are actually designed to eat hydrocarbons. And then you need to slowly, and I mean very slowly, raise your mixed liquor suspended solids, your MLSS. Do not shock them with a sudden load, or you'll be right back at square one.
All right, Section 4, acids and disinfectants, neutralizing the threat.
These are the culprits that cause massive pH swings or honestly just instantly sterilize your biology. If a factory dumps a massive load of strong acid or base, you've got to act lightning fast. In that golden first hour, cut the source and pump emergency neutralizers, like 20% sodium hydroxide for acid hits or dilute sulfuric acid for alkaline hits, directly into the equalization tank. Your absolute #1 goal here is to bring that pH back to a safe 6.5 to 7.5 before that water ever even touches your aeration tank. Over the next 24 hours, double-check your alkalinity and increase your return-activated sludge, the RAS, to try and stabilize whatever biomass you have left. Moving into the next week, you need to reduce your overall plant load by about 20 to 30% while the system heals. And guys, for goodness sakes, recalibrate your online pH sensor so you don't miss this next time.
A hit from disinfectants, stuff like chlorine or cyanide, is practically an assassin to your plant. In the first hour, you must cut the source and immediately pump sodium thiosulfate or sodium bisulfate straight into the equalization tank to neutralize that residual chlorine. For the next 24 hours, you monitor that dechlorination like a hawk. You want to maintain an oxidation reduction potential, your ORP, between positive 100 and positive 300 millivolts in the aeration tank. Over the next week, as you start adding fresh aerobic bugs back into the mix, you absolutely must keep the food-to-mass ratio very low. We're talking around 0.05 to 0.1. You have to give those new bugs time to acclimate without totally overwhelming them.
Moving to Section 5, First Hour Checklist, Emergency Protocol.
Brothers, listen to me very closely on this one. The first 60 minutes dictate the survival of your entire plant. This is the exact checklist your shift leader must physically sign off on. Number 1, bypass the toxic stream to the emergency tank. Physically go turn that valve. 2, get on the radio and notify production and environmental security immediately. 3, take time-stamped samples from the influent, the equalization tank, and the aeration tank. If you don't sample it right then and there, the evidence literally washes away. 4, measure the OUR on the activated sludge immediately to confirm the inhibition. And 5, check and log your baseline pH, DO, and temperature.
Continuing on with that crucial first-hour checklist, verify how much capacity you actually have left in your emergency tanks right now. Next, activate the plant alarms. Sound the horns, flash the lights, so everyone in the vicinity knows this is a code red. Prepare your neutralizing chemicals based on whatever specific scenario you suspect you're dealing with. Log the incident electronically and take photos of the conditions in the watercolor. And finally, you have got to report the situation to the technical manager within 30 minutes. Remember, communication is just as vital as turning those valves.
All right, Section 6, Prevention Strategy, Stop Future Disasters. So this right here is the ultimate lesson learned from catastrophic plant failures. Quote, never let influent pass pre-treatment without minimal physical chemical control points, pH, conductivity, and ORP. End quote. I really want you to burn that rule into your mind. You simply cannot manage what you do not measure. And running blind influent? That's just a ticking time bomb waiting to go off.
To build an impenetrable defense around your system, you have to follow these preventative measures. Install early warning sensors, and here's the trick. Set their alarms to trigger at 20% below the actual toxic limit. Give yourself a buffer. Force the production facilities to give you a mandatory 24-hour notice for any planned chemical discharges or tank washings. Buffer your plant by maintaining a hydraulic retention time, your HRT, of at least 8 to 12 hours in your equalization tanks. Always keep 20% backup seed sludge alive and ready in reserve. And finally, conduct these emergency drills with your entire team every 6 months. Muscle memory is what saves plants when everything hits the fan.
I want to leave you all with a very direct question, brothers. Think about your plant right now, today. Are your early warning sensors actually calibrated today to catch the next toxic shock before it hits your biological tanks? Please, don't just assume that they are. Go out there, check your sensors, verify those bypass valves, and protect your plant. Thank you so much for joining me for this explainer. Stay sharp out there.